Hello students, in this lecture we will discuss about numerical methods. So first chapter is numerical solution of equations. Before starting to the chapters, first we know about the equations. So first, what is algebraic equation? An algebraic equation can be defined as mathematical statement in which two expressions are set equal to each other. The algebraic equation usually consists of variable, coefficient, and constants. That means what? For an equation, there should be a left-hand side and a right-hand side. And the left-hand side value is equal to the right-hand side value. If this happens, then it is called equations. And an algebraic equation consists of variables. So that means the left-hand side have some variables with some coefficients or maybe constants. It also may happen for the right-hand sides also. Now, the algebraic equation, it's have two types. First is polynomial equation. So a polynomial equation is in the form, actually, this one is a polynomial form. So this is a x to the power n plus, or you can write a0 x to the power n, a1 x to the power n minus 1 plus dot 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 plus an x. An is equals to 0. So this is your polynomial form. Now, these are the examples: x to the power 4 minus 4x cube minus 3. This is equals to 0. So here it is a left-hand side and it is right-hand side. Now, this is, you can also write it as a function of x, and this is equals to 0. Similarly, this is another example, and this is another example. Here also one thing is that the maximum degree of x, this is maximum power of x, is the degree of the polynomial. So what is the degree of the first polynomial? See, this is 4. So the degree is 4. The degree of this polynomial is 4. Now for this case, the degree is 2. Maximum power of x is 2 here. So the degree is 2. Now for this polynomial, maximum power is 3. So the degree of the polynomial is 3. Now another type of equation, that is transcendental equation. An equation which contains polynomial, logarithm function, trigonometric function, and exponential function. If an equation has polynomial function, logarithm function, or trigonometric function, then this equation will be called as transcendental equation. Like this: tan x minus e to the power x equals to 0. Here you can see this is your trigonometric function and this is your polynomial function. Sorry, this is your exponential function. Okay, now for this example, this is your trigonometric function, this is your polynomial function, and this is your exponential function, and this is your polynomial function. So this is also a transcendental equation. Now similarly, this one is also a transcendental equation. This x is a polynomial, this is your exponential, and this is your trigonometric function. And also, you just remember, it is not like that all functions should have present there. That means you can also write it like that: x e to the power x minus x, this is equals to 0. That means here only trigonometric, this is your polynomial function, this is your exponential function, this is also polynomial function. So this is equals to 0. This is also a transcendental equation. And actually, what I want to say, that an transcendental equation consists only polynomial, logarithm, and trigonometric and exponential function. Okay, what I want to say, that not all should be present in an equation. कोई भी एक इक्वेशन में सबको प्रेजेंट जरूरी नहीं है, कोई एक या दो भी प्रेजेंट रहेगा, then this also will be called as a transcendental equation. Now see, if this is your a function, so any function y is equals to f of x, that we can draw as a geometrically, that is your y is equals to f of x. And if it is continuous, so that means the picture will be look like this. And this is your x equals to a, this value is actually f of a, and this value is actually f of b. If it is a, x equals to a, and if it is x equals to b, then this will be f of a and this will be f of b. Now, what is a definition of root? So, a number alpha for which f of alpha equals to 0 is called root of the equation f of x equals to 0. So, suppose you have an equation that is f of x equals to 0. Okay. Suppose you have an equation that f of x equals to 0. Now, you have to put the value of x, and for which value f of x equals to 0, this will be called root. Suppose at the point x equals to alpha, f of alpha is equals to 0. So that means alpha is a root of the equation. Now geometrically, one thing you can see, so a root of an equation f of x equals to 0 is the value of x, at which the graph of the equation intersect x-axis. See, at the point, if alpha is a root, then we know f of alpha is equals to 0. Now, one thing, you just see this picture. Say, at alpha, f of alpha is equals to 0. So that means this value at alpha, f of alpha is 0. F of alpha is 0, that means what? That means actually it lies on the x-axis. So an equation has a root. An equation f of x equals to 0 is the value of x at which the graph intersect the x-axis. This means if it has a root, if this equation has a root, so that means it obviously intersect the x-axis, because when it intersect the x-axis, then only you will get functional value of that point is equals to 0. Understand what I am to say? Root exists, so that means it obviously intersect the x-axis, because when it will intersect the x-axis, then on the x-axis, only on the x-axis, you will get the functional value is 0. Now, there are simple two definitions. Simple root. A number alpha is called simple root of f of x equals to 0. A number alpha is a simple root of an equation f of x equals to 0 if f of alpha equals to 0 and f dash alpha not equals to 0. It should be not equals to. Okay. So f of alpha is 0, but f dash alpha is not equals to 0. Then we can say that alpha is a simple root. And also here one thing you can see, if alpha is a simple root, then we can write f of x as this, x minus alpha into g of x, where g of alpha not equals to 0. Okay, so alpha is a simple root, so that means f of x can be written as x minus alpha into g of x, where your g of alpha not equals to 0. Now you can see for this example, f of x. Okay, so if you put f of 1, what we will get? F of 1 is equals to 1 plus 1 minus 2. So this is your 0. Now, what is the value of f dash x? F dash x is equals to 3x square plus 1. Now, what is the value of f dash 1? So f dash 1 is 3 plus 1. So this is 4. So this is not equals to 0. So now here you can see for x equals to 1, for x equals to 1, f of 1 equals to 0. But f dash 1 not equals to 0. So that means 1 is a simple root of the equation f of x equals to 0, of the equation f of x equals to 0. Okay, so x equals to 1 is a simple root of the equation f of x equals to 0. Understand? And also one thing you can see, x cube plus x minus 2. So this is, you can write x cube is, if you write x minus 1, so x cube minus x square plus x minus 1. So this one is x square minus x, so plus 2, x minus 1. So this is 2x minus 2. So that means x minus 1, x square plus x plus 2. Here what I have done, that is actually x cube plus x minus 2. So I have made some adjustment by like this. X minus 1 is a factor. So x minus 1, x minus 1, x minus 1, you have to write it. Now multiply x square, so you will get x cube. And here with this, so x square. Now in this term, there is no x square. In this term, no x square is present. So you have to vanish this term. So that's why I have taken here plus x. So this x, this is x square. Now this x into 1, so it will give you minus x. Now here it is 2x, and it is minus x. So you have to adjust by 2. So 2x minus 2. Okay, now adjustment is complete. So you can see x minus 1, x square plus x minus 2. Now, what I want to say here, x equals to 1 is a simple root. So that means f of x can be right by this formula. F of x can be right x minus 1 into g of x, where your g of alpha not equals to 0. Now you can see this one, you can see that this function x cube minus x minus 2 can be written like this, x minus 1 x square plus x plus 2. Now if you compare it, so what is your g of x? Your g of x is x square plus x plus 2, and you can see the value of g of 1, that is not equals to 0. So that means if x equals to alpha is a root of an equation, so simple root, so f of x can be written as like this. Now, another definition is multiple root. If alpha is a multiple root of multiplicity m, okay, alpha is a multiple root of multiplicity m, then f of alpha is 0, f dash alpha 0, up to m minus 1 alpha 0, but fm alpha not equals to 0. So take an example. So just see, this is x cube minus f of 3x square plus 4 equals to 2. So now here one thing we can first do, f of 2, check the value f of 2. What is the value of f of 2? So f of 2 is equals to 8 minus 12 plus 4. So this can 0. Now what is your f dash x for this example? So this is 3x square minus 6x. So again, if we put f dash 2, so it will give you 12 minus 2. So this is also 0. Now find f double dash 2. So if you find f double dash x, so this will give you 6x minus 6. Now f double dash 2, that is 12 minus 6. So this is not equals to 0. So that means 2. So here, from here we can say 2 is a double root. Okay, double root of f of x equals to 0. Okay, I have understand what is multiple root. So 2 is a multiple root and the multiplicity is 2. Okay, and here one remark you have to remember, that is, if your equation is a polynomial equation, then the number of root is equals to the degree of the polynomial. Okay, suppose your polynomial equation whose degree is 3, so that means number of root is 3. But and also the nature of the roots may be real or complex. That many things may happen. But if your equation is a transcendental equation, then you cannot say how many number of root is present there. Okay, if your equation is transcendental equation, then may have one root, infinite number of root, or no root. Understand? I hope you understand it. Okay, next section. In the next session we will read about solution of an algebraic equation and transcendental equation, so which is included in your syllabus. So in this section, we will learn three methods: bisection method, regular Falsy method, and Newton-Raphson method. Okay, thank you for watching the video.